Ron, should we start? Okay, let's start. Hey folks, welcome again to our workshop. I know we've had like series of demos and workshop today. First of all, thanks for being there at day 3 of DSS 2021. It's been exciting conference so far, great set of questions from the audience, and we hope this hands-on workshop today with Yugabyte and Spark is very beneficial to you. We've definitely gotten some live real-world examples for you, so please follow along, and whenever you have any questions, please keep them coming on chat. We have a set of engineers from Yugabyte who will be happy to answer all of your questions. So before we start, just wanted to highlight that this is going to be a hands-on workshop. So if you don't have your Yugabyte cluster up and running, please go to Yugabyte Cloud console and spin up your cluster. It will take about 7 to 8 minutes right now, so it's a good thing for you to get started. And until then, we'll try to cover slides as much as possible. So with that, just wanted to introduce myself. My name is Amey Banarse. I lead the field engineering team here in Yugabyte. So essentially a team of engineers who work with our customers and help them modernize their legacy database into Yugabyte distributed SQL database. And also we help them build production-grade data pipelines. So essentially Spark, Kafka, Apache Pulsar, Flink, whole bunch of reactive services like Akka-based, Akka Stream-based, are the ones that our team helps customers day in and out, eventually using Yugabyte as a serving layer. So what we have done today is taken one of that abstract from the data pipeline and doing a workshop with you folks on that one. With me, we also have Wang today. Wei, do you want to quickly introduce yourselves?
Yeah, thank you, Amey. Hey, everybody. Yeah, welcome to the summit. Really excited to have you here. My name is Wang, so I'm a sales engineer here with Yugabyte. So I have been working with customers across the industry, help them really to build efficient data supply chain, right? So I have been working with all kind of database technologies, from legacy, ones from like Oracle, SQL Server, all the way to cloud native, like BigQuery, Redshift, AWS, Azure, anything in between, vertical, all kind of database, right? And NoSQL in between too. But I think Yugabyte is one kind of database, right? That's why I'm so excited to be here, and I hope you'll be excited too. And Amey is going to tell us why, right? Amey, back to you.
Thanks, Wei. And folks, Wei is the master of databases, not just jack of all databases, master of one. He's actually master of a lot of databases. So in his career has been spanning OLTP, OLAP, and new age cloud data pipelines as well. So please keep your questions coming. If you ever want to chat with us offline, we are available on Yugabyte Slack channel or LinkedIn. Come and talk to us at any point. So with that, just wanted to lay out the agenda for today's workshop. Since you folks need a cluster for this, we'll give you about 8 to 10 minutes to go spin up your cluster. During that time, we'll do a quick architecture overview of Yugabyte. We won't get into any depth because you've heard a lot about Yugabyte over the last 2 days in Yugabyte's DSS conference. So feel free to go and take a look at any architecture details from our documentation as well. For this workshop, we're going to tap into Yugabyte's YCQL API. So that's the semi-relational Cassandra-compatible API, since it works really great with Spark. And we're going to show you this live example of how you can use Spark SQL and windowing function to do read and write data from Yugabyte. So that's going to be the crux of today's workshop. And obviously, to help with that workshop, we have built our own Yugabyte Spark connector. So this is inspired from Netflix and DataStack's Apache Spark connector. But we have done a whole bunch of performance optimizations and would love to cover how those optimizations come into the play in your real world scenario. So at this point, folks, if you haven't done that so far, please go ahead and grab this GitHub repo. It's Yugabyte/Yugabyte Spark workshop. You can clone it, and this is the exact workshop we're going to follow step by step. So with that, since you folks are all here, you know about Yugabyte. We essentially started Yugabyte in 2016 to solve some of the hardest problems in the database industry. So that is, Yugabyte is a brand new database built from scratch, which gets you transactional, strong consistency, and distributed asset semantics, and takes care of some of the hard problems like resilience, HA, and scale built into the database architecture itself. And with that in mind, we always keep developers and architect on top of our minds when it comes to ease of use and ease of access. So that's why we went to the market, look for the best two APIs that we can bring you in this brand new database. And that's why Yugabyte is 100% Postgres compatible as a relational API. And also, we derive some inspiration from Cassandra API, but we have made it more transactional. So we also have a Cassandra compatible API. That will be the one that we'll be using in today's workshop as well. Nonetheless, we made sure our product is 100% open source. So you can go to GitHub, browse our code, download anything, or contribute anything. We'll be happy to take your contributions. And there is no platform lock-in in Yugabyte. That is, you can deploy Yugabyte across VMs, bare metals, containers. It doesn't matter. You get the same exact experience, the same exact semantics from the database itself. With that, this is how each node of Yugabyte looks like. That is, when you spin up your Yugabyte Cloud for this workshop today, obviously you don't have to worry about the complexities and everything behind the scenes, but this is how your Yugabyte looks like. That is, there is a lower half of the database, which is inspired by Google Spanner. We actually brought Google Spanner to open source live. This is what we have done. This layer provides you strong consistency and asset semantics. And then on top of that, we have a Postgres compatible API so that we reuse Postgres as is. And we have a Cassandra API compatible API as well. And we do a lot more on that API than just pure 100% Apache Cassandra. So what do we do a lot more? And this is exactly what you're going to be seeing in our today's workshop. That is, other than the Cassandra API that actually our founding team wrote in Facebook, we actually support strongly consistent secondary indexes on Cassandra. So this is very important because when you will be developing Spark-style application or real-time applications which need strong consistency and you cannot afford to have any dirty read or phantom read kind of a scenario, this is why you should use Yugabyte for serving the strongly consistent reads using your secondary indexes. Second thing is, since MongoDB has taken over the world from JSON perspective, since they introduced it about 12 years back, we also natively support JSON as a data type in our core document storage engine. So we'll be using JSONB as one of the data types in today's workshop so that you can natively do document-oriented queries in Yugabyte without having to worry about anything. Third and fourth, that is, Yugabyte is a distributed SQL database, so you get a full control on your data residency compliant requirements. That is, you can essentially optimize your Yugabyte architecture and Yugabyte database to optimize for low latency reads or high throughput writes. Everything of that is fully controllable. We give you the hooks to go and do it. In terms of the versions of Cassandra API that we support today, we support 3.9x of Cassandra CQL and 4.6.x actually. So we are compatible with the latest Cassandra upstream so that you don't have to worry about any syntactical changes in your applications. Now, with that being said, just wanted to drill deep into how do we do this? How do we get you secondary indexes with strong consistency in Yugabyte, right? So imagine this table. You create a simple DDL. You say, I want to create a product ranking, create a main table. I assign a primary key. It's a composite key in this case. I go ahead and create a secondary index on top of this product rankings with a category, sales rank, and ASIN. Very simple. This gives me an ability to go and look for top products in a category just by doing this query. Internally, Yugabyte would go create a separate table and use this as a parent table. And this gives you strongly consistent asset semantics. That is, I can now query from the primary table, and that's let's say query by ID, get me the data for that ASIN or that object ID. I can now query my product rankings table, which if I specify a category, it's going to tap into the secondary index and give me strongly consistent results. And this is where we are not different from Cassandra because Cassandra's secondary indexes were an afterthought. They were actually developed 4 to 5 years later in the code development. They were never able to get a transactional compliance with that secondary indexes capability. But this is where Yugabyte is significant. That's number one. Number two, let's say you create a transactional application. So I create a simple orders example, and I create a whole bunch of fields inside that table. I just have to give it a hint saying that please enable transactions for this table. That's it. Now, with Yugabyte, since we are an asset compliant database, we actually support this syntax in your Cassandra API. That is, you can say begin transaction, update a table, insert something into another table, and end the transaction. This entire transaction block allows you to do a multi-row or a multi-shard ACID transaction at scale. This is all taken care by the lower half of the distributed SQL database that we have built. So you can essentially go and do a ACID compliant checkout or ACID compliant shopping cart in your application without having to worry about anything when it comes to data inconsistency issues. Number three, this is what we're going to tap into. That is, we'll have a JSONB data type. It natively gets stored in Yugabyte as JSONB. We don't do any conversion. We don't have to worry about any encapsulation. So you get a pure JSONB performance when it comes to that. And we also going to demonstrate you the column pruning aspect of it so that you don't have to read the entire JSON payload at any given point. You can actually prune the attributes and columns to make sure that your performance for your application is significantly faster, and you don't have to do any client-side filtering. So it just helps you with overall optimization of your application as well. Last thing, we don't need to introduce Spark at all. Most people who are attending this workshop would know what Spark is. For folks who are new, again, think of Spark as an in-memory computing application. That is, it basically allows you to parallelize your computing application in a way that you can read data from any tables or objects, files, or any database like Yugabyte, do certain computing. So in our example today, we are going to be doing windowing functions, and then dump the data back into Yugabyte so that you can use Yugabyte as a transactional serving layer for your application. With that, Yugabyte has developed a Yugabyte Spark connector. It's one of the only connectors out in the industry which natively supports JSONB and allows you to do performance optimizations with predicate pushdowns. This is important because we take your predicate from your queries, we push it down to the lowest layer in the storage so that we only fetch the fields or write the fields that are required by your application. So this becomes very handy when you have large set of objects that you're using in your Cassandra cluster today, and you have to keep reading and writing these large objects on the client side, and you have a lot of onus on the in-memory component in the client side. All that goes away with Yugabyte. So this is exactly another thing that we're going to be using in the workshop today. Now, this is what we'll be building in the workshop. We are about 12 minutes mark right now, so hopefully all of you have your clusters created for Yugabyte because things are going to get very real from this point. That is, we're going to have Apache Spark for this cluster. For this workshop, you can just run Spark single daemon on your laptops, or if you're using EC2s or anyone, doesn't matter. You're going to be deploying and developing the Spark Scala application. So it doesn't matter if you're not a Scala expert. Wei is a Scala expert, and he's going to take care of teaching that to you today. So don't worry about that part. And then using Yugabyte Spark connector, you'll be reading and writing data into Yugabyte and doing certain ETL jobs and using Spark SQL to do a windowing function as well. So with that, Wei, do you want to give us a quick overview of what we're going to be doing in the workshop?
Second, Amey. Yeah, so just like Amey was describing, so this workshop really is about, I think, a couple important points, right? One is, what is required to build a Spark app target to Yugabyte Cloud, right? So about lots of both, what is required really to make it happen. I think that's the most important thing, right? The second piece really is we want to demonstrate a unique feature of YCQL API, which is the native JSON support, right? So we want to demonstrate you can do column pruning, you can do predicate pushdown, and you can do any transformation in between, right? So as real-time data processing. So this is two main perspectives we want to demonstrate to you. Thank you.
Perfect. Thanks, Wei. So, Wei, do you want to start sharing at this point, and we can have folks follow your terminal? Yeah.
Okay, let me just share. Let me know when you see it. Okay. Okay, everybody see my desktop? Are we good?
I think so. We are good. Yeah. Can anyone confirm on the chat that you are able to see Wei's screen, please?
Yes. Okay. Good. As Mark replied. Yeah. Awesome.
Thank you.
Okay. So I'm gonna go to this GitHub. I'm gonna open this tutorial here. So we wrote for this workshop, right? So how is found? Everybody see it? You can feel free to download from GitHub, right? So we list here the prerequisites for this workshop. Apache Spark 3.0. Hopefully you have it installed. Does everybody have a Yugabyte Cloud cluster created? So that's the two main pieces we need, right? Spark collector, which is in the Maven, we just grab it from there. And the Scala 2.12 come with Apache Spark 3.0. So you should be good to go if you have a first two piece up running. So with JDK 1.8, which is required. So if I can show you YB Cloud here. So I have this cluster created here, right? So this is called YB Spark demo. If I look at the setting here, on the right side here, you can see IP allow list, which you add your IP to this list, so which enables you to remote access to this cluster. So that's from a working perspective. You need to get it working. Or you can always configure from here, add IP address. You do detect and you just add from there, right? So there's another option to do. Otherwise, from here, this basic matrix, right, for the cluster, operation, CPU usage, disk usage, all the, so it's good and nice to have it here, so you have some high visibility of what's happening, right? And you can look at table here. There's two APIs like Amey was talking about, right? So today we're primarily focused on this YCQL, right? So those are case space. Create a few case, couple case space, some sub table data here as for the demonstration perspective, right? So you can see from here. So any questions here? Okay, otherwise I'm going to continue to walk through here. Let me go back here to this. I have a file called namespace.sql. So once you have access to Yugabyte Cloud, right, so you can log in to create this case space here. In this case, I got a k-test, right? So create a few a couple tables here, right? One is we call employees JSON, right? So if you pay attention here, the font, which is JSONB, right? This is very native support for JSONB, which Cassandra doesn't have this, right? So then we have a data type of this, so it's very different. And then you have primary key here. So another table I created here is just like I demonstrated, right? So for unique secondary index, this will basically enable transaction and create index as a demonstrated purpose, right? So can everybody see this one well? I mean, this is quite small probably. But basically, I just show you, I create the employee JSON table here to show you how the table looks like in the real database, right? So we have a transaction enable. We have primary key. Obviously, we have default time to live. This way, we set it 0, but you can set it to it's not whatever you need. It's like it's basically the auto expire your data sets, right? Which is a nice feature. So let me go back to here again. Any questions so far? Okay.
Maybe I think it looks good. So okay. Folks, please namespace.sql file if you want the DDL, and please go ahead and create those tables and namespace in your Yugabyte cluster.
Okay. So now I'm gonna, once everybody has a class up running, have a table space created, so what we're gonna do next really is just to go through the Spark file here. This, like I talked about earlier, is very straightforward, all right, Scala application. But we want to demonstrate how you actually can work with the Yugabyte Cloud with those components required, right? So I'm going to walk us through here briefly, and I'm going to run through with the Spark share. So feel free to, ask any questions. If you want to stop, a couple, minute to catch up, that's fine. Just let us know, okay? So first part is that, just like everybody does, right? Spark, you import, necessary libraries here. I think for us, primarily we'll focus on Spark session, Spark conf, right? And we'll have some dependency on, data stack concentric collectors we import here. So I'm gonna just go ahead and import this library here. Oops. So everybody see this window, right? Okay. I'm gonna move up a little bit. So basically, I'm gonna use a Spark collector, which is developed by Yugabyte, right? So we're gonna use this collector 3.0. So I'm gonna invoke Spark share from here. Taking like 30 seconds probably to get up running. Okay, so as you can see here, this is Spark 3.0, right? Then we have Scala version 2.12, so which is we're good, right? So we have a GDK here 1.8. So that's everything we need is here. So first step, I can just import this library, so we just copy it from the file, right? So then next step really is this here is the important piece here, right? So where we got this, collectivity information to YB Cloud, right? So if you go to YB Cloud here, you go to the cluster, right? Use Yugabyte Cloud share to collect, or you run your application. You really, in this case, we're going to just go to the run your application, right? Obviously, in order to collect, you need to download the cert, right? And create a trust store file. But that's everything's in the README documentation. For us, really, if you go to YCQL API here, you can say this data center is US East 2, right? This is host name as port number, right? So now if I go back to here, you can see this is we have other information. This this just case space table is not critical here. We just have a host information, case store we created with the certificate, and this password for the database, right? Database uses admin by default. This password. When you create a cluster, it asks you to download your credential, which is this is from the credential download. So this is what we're going to do. We're going to create these variables here pretty quick. Okay, so far so good. The next way we're going to create a Spark conf, right? So this here, the only thing really, we run Spark local, right? So, this data center local data center is US East 2, was just solved from the Yugabyte Cloud, right? Okay, so then we're going to create a Spark session, and this session is going to specifically collect to the Yugabyte Cloud database, right? Because this is some, too much space here, I just put in the one line to make it simple for the live dev perspective. But as you can see here, it is all these variables we created previously, right? It's passed here, your username, password, the trust store, when labeled SSL, right? So basically all the information required to collect a database. So I'll copy this command here. So I'm going to create a session. This doesn't matter. There's some exceptions, but yeah. So once we create sessions, now we can, really, since most of you have a Spark background, really becomes much simpler, right? So you collect to the Yugabyte database, right? The first thing I'm going to do, I'm going to show you, just like I showed you from Yugabyte Cloud interface, right? I show you what is namespace or case space we're creating in the database, right? So this is Spark SQL. I just run very simple Spark SQL here. Come on. Yeah. So as you can see, right, so we have a multiple, some of those really system case space we create a store at a test, right? So in this case, the case space we create is there. Right. So next step, basically, this is probably one of the important steps I want to spend a bit of time on. So basically, we use Spark read, this particular API, right? So basically, this uses Spark collector to read the data from a YCQL table and read into we create data frame, basically, right? So that's all it does. But the most important thing here really is, when you create a Spark application, really is, be aware of partitions, right? This is really a number one tip, really. So how many partitions you have in the Spark, how your data is actually stored in the database, right? Since Yugabyte is distributed database, right? All data is partitioned to tablets, right? And it's spread across different nodes. So therefore, understand how data actually stored from database is the most critical piece for the collector, right? If you recall, I may mention, this collector is partition aware, right? As you have a lot of metadata awareness, right? So it knows where data reside and can fetch very effectively, right? So this is one of the important features for collector. So now I'm gonna run this command, create a data frame. Okay, so since we don't have that much data, it's just pretty fast. So we created a data frame called dfyb, right? So I can just copy command instead of a type of it. I'm gonna do that real quick. Do the count. We know it's a few rows over there, right? Yeah. So I have 7 rows over there, and then we're gonna do let's display data sets, right? So I'm gonna put this first, so you can see you need more information. Sorry. Okay, so now you actually just say, those different data types, right? We have department ID, employee ID, and department name, right? And you can see this JSON format here, right? So this is actually, we fetch the entire data sets from a YCQL database. So this is really, it's very straightforward, right? So you basically use a connector, will pull the data from, right? And pull the entire data set from a table. Now, so we want to do based on this data frame, right? So we want to do Spark SQL. We're going to use Spark SQL to do some window function. If since you guys know Spark works, Spark really support multiple group, multiple categories window function, right? One is ranking, so that's what we're going to do. And it does support aggregation and analytic function like lead, lag, or max, mean, all different categories. But in our case, we're going to simply demonstrate, how can you create a window function. You partition table by department ID and you order by salary. We get the ranking, say who make the most money and for the given department, right? So it's very simple window function that we're going to create here. All right. All right, so now as you can see here, right? So we have multiple departments here. We have HR, IT, sales. This box number here, but this is the point, right? So we basically partition it by department ID, right? So what we're going to do is we're going to do the quick ranking for the result sets, right? So now you can see, right, because it's such small data set, you can see we create the ranking, okay, for each department, who make the least money, right? Because we all the reverse order, but number 3, make the most money, basically. It's a very simple example, based on data set you retrieve from database, right? You can perform all the computations you need based on, your particular problem you try to solve, right? And you do the transformations, data cleansing, anything you want to do, right? So once you have done that, so next step we want to do really is we're going to persist some data, right? So in this case, we just take an entire data set, but you're going to persist this data back to the Yugabyte Cloud in this case, right? So I'm going to just do this real quick here. We're going to write this data frame, right? Write it back to. Okay, so basically in this case, you persist the data back to database, right? So we can do simple Spark SQL here, do like a quick query. Spark SQL is really convenient, right? But do some very simple ad hoc queries, right? But just be aware Spark SQL really is very difficult to control in terms, not of configuration performance wise, right? But it does sometimes very convenient for you to do some spot checking, right? So basically this data set that we rolled back to Yugabyte database, basically, right? The YCQL. So this is a first part of this demo. Really is how you use Spark and Spark Yugabyte collector talk to Yugabyte database, right? You read the data, you do ETL, and you write it back. Basically, it's a very simple 3-step process, right? But hopefully, give you ideas. Say, okay, how you actually interact with the Yugabyte cluster. And so this is basic stuff. So, any questions? Otherwise, next part I guess really focus on basically explain to you how we support JSON in native format. Right, so that's one of the most important features I want to demonstrate to you. And this is a very unique feature. Cassandra doesn't have it. Mongo is pretty good at it, right? But we do much more than Mongo can provide. This is very, I think it's a very exciting feature I want to show you here. All right, let's do this one. Yeah, I can just go straight to this. What rate is that? Our same thing. Oops. So if you look at SQL here, right? So we call the function called the get a JSON object. And then we're going to get a specific field from the JSON, right? So this is called the column pruning. You don't need to get the entire payload from the JSON, right? You just get any fields you want, right? You extract out. So that's the whole idea here. Then another function here is we call the get a JSON string. It does just subfield over there. And really, when you run this, basically, let's say result sets. And if I go back here. So I'm going to execute this query, right? Then let me do explaining plan. You can see what this explaining plan looks like, right? So if you can see here, right? So consider filter, right? So we actually indeed, not only we did the column pruning, right? So we select a specific field, right? From the entire JSON payload. And we push down the filter to the storage layer, right? A database layer. So this really effectively shows you how we can push down the predicate, right? When you build a large data set application, right? So this is very critical because you want to apply your filter as early as possible in your process, in your application, right? So in that particular case, you push it all the way down to database layer, and you client, you get it back a much smaller data sets what's required, right? So if you have a 200 or 500 column of data sets, right? You only get 5 back, right? So this obviously, you push down dramatically, and not only in terms of column pruning, but in terms of number of rows, right? If you filter by a specific phone number, for example, specific email ID, for example, right? You get a significant subset, a small set of data sets, right? So that's a really, very powerful feature. So, your application can scale, right? So, so this column pruning here, the predicate push down. This query is very similar, right? So I'm going to show you here too. And so we can show some result sets. Now we can do the explaining plan again. Okay, so in this case, even we only have 7 rows, but in this case, we only return 1 row, right? Because we apply the filter in the database, and your client only get back 1 row. And now if I do the explaining plan again, right? So look, this is very similar to the previous one, right? So we push down the predict, right? Push down all the way to the database layer. And from the Spark perspective, you only got, one row to work with. So therefore, then, because of those unique features, right? So you can easily scale your application really based on amount of data, right? Complexity. So this is, those are most important features I wanted to show you from a Spark perspective, Spark collector perspective, right? So you can effectively apply to interact with the database Yugabyte YCQL API. So any questions in the chat window?
I think Richard has been answering a lot of them. So
awesome.
Folks,
yeah, thank you.
Column pruning is very important because this will just boost your application performance at any given point, right? You're not trying to look and load the entire JSONB, so you can actually send down those predicates as you saw Wei doing it. And more importantly, just imagine if you're doing like 500,000 or 1 million ops per second. This is just going to get you a huge boost overall. So it's a very important feature that we have developed. Now, so folks, I hope you followed this example until now. But if you have any questions, please send them on chat right now.
Yeah, I think just to summarize what we did, right? I think a few things we want to point out. One is really be aware of the partitions, right? When you interact with the YSQL database, right? Because the way we store our partition data, right? And the way Spark partition data. Obviously, you can read the data into the Spark and you can repartition, but always understand how the data stored in the database is going to help you out when you design Spark application. I think that's number one. Number two, we talk about we want to apply filter, right? So predict push down is the most important way for you to apply filter early, minimize impact to your application, right? So typical database is much powerful, has much powerful engine to process not data sets in your application server, right? So that's number two. Number three, so, we talk about Spark, SQL, but really, you just understand Spark SQL has limitations. If you can use, connector, talk to database natively, that will be preferred way because, you have, the collector understand database much better than generic SQL against any other database, right? So those are unique things I would, recommend.
Thanks, Wei. This is great. We can just share the screen. So folks,
sure,
now we can talk about how you can take this workshop and apply it into some real world examples, right? So one of the things that Yugabyte team has basically done is created a real world example of this kind of workshop so that you can actually apply it to an IoT style scenario. So what we have done is we've created this GitHub repo for a sample project called Yugabyte's IoT Fleet Management. So essentially, there will be a simulator which will just assume that you are a fleet management company who wants to track a whole bunch of vehicles that are out there. Like, I think we have like 18 different types of vehicles in here, like wheelers, buses, large trucks. And you will essentially build a sample dashboard to just keep a track of like what is the traffic and everything. And we also give you a simulator to basically go and simulate that, what is this vehicle doing and a whole bunch of things. So what we have done is, as an inspiration for this workshop, we also put together 2 different ways of solving this problem. That is the IoT traffic management problem for you. One is using Confluent Kafka, that is taking the data from IoT sensors, putting it through Kafka pipeline. Remember that Yugabyte has a Kafka Connect sync, and now we are in the process of building Kafka Connect source as well. So you can do live aggregations and filtering using Confluent's KSQL, and then dump the data into Yugabyte so that it acts as a serving layer for this dashboard. And this is going to be a real-time dashboard. Option 2 is we have taken the same data pipeline, but we have now converted that into Spark streaming application. So that is, you're going to have Kafka as a data pipeline, essentially to go and take this data from IoT sensors. And then you're going to use Spark streaming and Yugabyte to collect that data, create these micro aggregates, and dump the data in Yugabyte so that you can serve it from Yugabyte as a serving layer for your IoT management application. The entire thing is available here in our GitHub repo. So please go ahead, get a feel for how you can actually deploy a real world example using this. If you have any feedback for us, please send it to us on Slack or anywhere you can find us. And please clone this repo. We are happy to take any of your suggestions or commits as well. So hope this workshop was helpful, folks. Thank you again for attending it, and please continue with DSS. We have 2 more workshops coming in. The next one is going to be the Hasura GraphQL workshop, and one after that will be Spring Microservices one as well. Thank you.
Thank you, everybody. Appreciate it.
Thanks, everyone. We are going to try and start the next session a little bit early. So just bear with us for a couple of minutes and we'll send you the link when we get started.